Okay, so a couple things. I handed out a short little assignment yesterday, and if you handed it in, I did mark it, so I can get that back to you. If you didn't grab it, I have a couple more copies left. I didn't get that one, did you? And all I did was record if you handed it in or not, right? Because, again, I'm just using this back for assessments. So, let's see. Rahel, let's take a look at Jack. Is that what you're saying? Joanna and Adam. So just quickly, and do you have yours, Dee? And okay, so if you want to look quick, and I don't have yours, I'll quickly mark yours too, Dennis, that you just handed yours in. But if you just take a quick look, I'll just show you what the answers look like, and then of course, you can hand yours in to me again if you haven't quite finished yours, or if you just got yours today, you can still hand it in. But I'll just quickly go through. All right, so we have two, I think everyone who handed it in got this, no problem. We have two shifts, right? The first graph, and I notice how I identified which is which. Some people use different colors, that's fine, however you identify them. So this is what shifts look like. Here, the only thing I want to say about this the second graph is Part A was done quite well, I think. If we look here, it was a vertical compression and then a reflection, a vertical compression, or actually no, this one. Part B was done well. It was a vertical stretch and then a horizontal expansion. So that's this, hopefully you can see this. I did it in pencil, so it maybe doesn't show up that much, but it's this one, right? So we can see it's a vertical expansion by factor of 2 and a horizontal compression by a factor of 2, right? So the graph gets taller, the graph gets wider, correct? However, this one, part A, vertical compression and then a flip over the y-axis, right? So vertical compression, that means the graph gets shorter, so you can see it did here, right? But then a flip over, or reflect over, the y-axis. So if this shape, if my original shape gets flipped over the y-axis, what happens? It's pointing in the other direction, right? So for all those people, I'm going to do this one a little darker. So here's my, this leg becomes this leg. And then I've got my little short leg, and my arrow should be pointing in the other direction, right? I think one person maybe had the arrow in the other direction. So this is the starting position, this is the ending position. If there's a reflection over the y-axis, then my original graph, which was here, is pointing in the opposite direction. Be careful on that. Here, -12, -6, I think everyone got that. Everyone got this too. The domain was 2 to 11. And then the range should be 3 to 15. When you do the multiplies, this becomes -3 times -5 becomes a positive 15. So you just had to make sure you arranged your range in the proper order. This was a bit of I think this was a problem. And then these were fine, okay? So if you handed yours in, notice that this is my A value, correct? Agreed, everyone? A is 5. So if I have a translate 3 to the right, this only affects the x value. Okay, so only anything affecting the x value is isolated in brackets, right? The 5 is the stretch. This is the shift, so they have to be separated, so it's 5 bracket x minus 3 plus 2, or you could simplify it through collect like terms, and you'll get 5x minus 13. Okay? We're going to talk more about this today, though, when we do our combinations. Okay, so let's get back on track, and you can come see me if you have more questions. So we got, excuse me, we got to the end of the stretches and compressions, and today I'm going to talk about combinations and transformations. I guess first, were there any homework questions? I left you off in class yesterday working on homework, so let me know. Yeah. Always the smaller number first, yeah. Always. Okay, so, and I also noticed there's a page missing. I guess the printers, again, our photocopy office, where we send our stuff. I was flipping through last night, and then I flipped it through the master. The master is fine, but my package goes from page 41 to 43 to 40. Oh no, I have 45 and 47, but I think aren't you guys missing a page? Yeah. So somehow it must have stuck together in the print office. So I have to get that an extra page photocopied for you, and all of our printing is down right now at this building. So I will get that to you as soon as we can. I've left a note with the librarian, and she's going to help me out there as soon as our printing gets going up. So let's take a look at lesson 3. Oh, sorry. Were there any questions on assignment 1.4? So number 5, yeah, this one was, it says beginning with the graph of x squared, as shown below, sketch the graph of the compression to, and I would say this is a vertical stretch, to be honest. Okay, so, okay. I would say this, I would recognize this is, I think the easiest way to approach this is a vertical stretch by factor of 3. Would you agree? Would you look at this and say the only difference from here to here? This is your given graph, agreed? This is what they asked you to do. The only change I see is an A value of 3, right? Even though they want us to recognize this as a horizontal compression, it's way easier to recognize it as a vertical stretch, right? And with quadratics, like I say, it can be either or, right? It can be an A or B value. When we do our generic combinations today, we're going to see there's not going to be any ambiguity here on any. Do you know what I mean? So you won't be ever confused. So I see a vertical stretch by value of A. So what does that mean? Every y value is multiplied by 3. Agreed? Okay, so if I use our same system, if I use my mapping, I guess, my mapping technique, I have this point, and this point. It's a little hard to read these. This point from here to here is -2. This is -1. So I have a -1 for x, a 0 for y. This point, I'd have 0 for x and, well, it has to be -1, right? Because they gave me that equation. And then finally, my last point, I have a 1, 0. That's all I really have to work with, for me, to be honest, because I don't really know what this, I mean, that would be like 1.5. That'd be a little hard to use. So I'm just going to go by these 3 points. The only difference is a vertical stretch of 3, so my x is going to stay the same. I'm going to multiply every y by 3. So my x's are all going to stay the same. I'm just going to record those. This multiplied by 3 just gives me 3 times 0 stays 0, negative 3, and 0. Okay, so let's see what we got here. I've got negative 1 and 0, 0, negative 3, and 1 and 0. Whoops. 1 and 0. And you know what? That's about all I can do, to be honest. Done. So this would be y equals 3x squared minus 1. All right, that's how I would do it with transformations. What's another way you could graph this? What's another way you could graph 3x squared minus 1? What's a standard way to graph that some of you might have done? A strategy. Jack, did you do something different? Did you do table of values? You can always do table of values, right? Sometimes it's a little slower, but you can always do table of values, right? I think the words were a little confusing on this, and it was hard to read the graph again, right? But we okay with that? Okay. Anything else on this assignment? I told you to leave number 7, unless you've got really great eyes and you can decipher the scales, but I thought that was hard. We good? Yeah? All right. Okay, I'm going to do combinations. I know your book does reflections and inverses, but we're going to do combinations and then come back to, maybe we'll try reflections today too. We'll see how we go. Combinations are probably the trickiest though, so I think we're going to try and, I probably won't get to reflections and inverses today because combinations are tricky. We've got, given the graph of y equals x, sketch its, I'm on page 15 of your booklet, sketch its image after horizontal compression by a factor of a half, a translation 3 units down, write the equation of the new function. Okay, so we've got two things to do. We're combining two transformations. One is a horizontal transformation, one's a vertical. They want us to write the equation in terms of f of x. So what do you want to do first? Do you want to graph first or write the equation? Does it matter? You want to do the equation? Okay, what would the equation of the new graph be? If I'm multiplying by a factor of a half, and I have to write it in terms of f of x, right? If I multiply every x value by a half, that means my b value is 2. Okay? So that's what this means. Horizontal compression by factor of half. The b value, which is the value that goes into your equation, is the reciprocal of 1/2. This means b equals 2. Okay? 2x and a translation of 3 down. Okay? Agree? Do we agree with that? Okay, so now I'm going to do the graphing. So here's my new equation. This is the new equation. And now let's do my graphing. So I'm going to stick, like I say, I'm going to stick to my mapping approach. So I have to identify my values. 1 tick is 1 unit, so -6, 2, 0, -2, 2, 5, and 5, 3. All right, be careful. The math that I have to do, the arithmetic that I have to do, it says I multiply by every x by a factor of a half. And the changes on the y, it's just going to be y take away 3. Agreed? So the y's are really straightforward. They kind of match what's going on with the equation. The x, if the equation looks like a 2x, to do the mapping, I'm multiplying by the reciprocal, right, to find the new value of x, because that means a horizontal compression. Okay, so again, you can do this whatever approach you want. I usually stick to one variable and I do all my one variable. I just find it easier that way. So half of -6 is -3. This remains 0. Half of 2 is 1. And I'm just going to record this as 5 halves. which is 2.5, right? Okay, so I'm just going to subtract 3. Every y value is subtract 3. 2 minus 3 is -1, -5, 2, and 0. Okay, so all I have to do is plot these and connect in the right order. So, -3, -1, 0, -5, 1, 2, and 2.5, 0. Okay, so I'm expecting, the words told me, horizontal compression, so I should be getting narrower, and then a drop. It looks like my points are going to result. Okay. Does that look like a horizontal compression and a drop? Yeah, I think so. And I'm going to, beside this, I'm going to write in my new equation. Okay. Again, ask me questions if there's something you're not sure of. All right. Now let's do the next, we're kind of leading up slowly. You can see example 3 and 4, they involve lots of changes, right? So kind of working our way up slowly. Given the graph of f of x, describe and sketch the graph of y equals f bracket 4 bracket x minus 3. All right, can someone verbally explain to me what do you see here? Because it's not telling me. Here it told me what the changes were too. This time I just have to read it from they're giving me the equation and I have to read, I guess read them from the equation. I see 2 changes here. I see this 4 and this 3. Someone want to give me, what does the 4 represent? A horizontal? Yeah, so I have a horizontal compression. By a factor of 1/4 and a horizontal shift 3 to the right. So I have both of my changes are on my x value. Okay. So let's pick some points. And again, a little trickier because they don't give us points. So we have to pick a couple of good points and hope that they can work for us. How about this one? It looks like it's -5, -10. And then of course I'm going to pick my intercepts if I can, and I can. So -4, 0. This point, 0, -15. This point, because this is just such a wide graph, I'm picking a few, I guess I'll pick a few more points than I normally do, right? 4, 0. And then the last one, I should have a matching one over here, right? It's about, might not be exact, but 5, -10. This is a nice symmetrical shape, right? It's like a parabola with something weird flipped over. Okay, so the math that I have to do, I have to multiply every x value by 1/4. Well, this is going to be a pain, isn't it? 1/4 times x, and shifting 3 right. What's the math that I have to do? +3. Excuse me. All right, and then is there any change on the y? Nope, so it just stays. Okay, this is going to be a pain in the neck. Negative 5 times a quarter, that's just, I guess, negative 5/4. I made it hard on myself, didn't I? Is there a better point I could have used? Do you want, maybe I'll change this to, yeah, is that better or does it matter? What do you think, guys? Is there a better point I could use? If I did -6, I'm still going to end up with 6/4, right? Ugh. Let's just forge ahead. Okay, so this is negative 5/4, right? Plus 3. How good is your addition of? Okay, so this is like, let's try this. What's negative 5/4? It's negative 1 1/4, right? Negative 1 1/4 plus 3. So that would give me 2 3/4? Or 1 3/4, right? No. Hang on. I need my calculator. Negative 1.25 plus 3. It's 1 3/4, isn't it? Yeah. Okay. Is 1 3/4. All right. So that's my x value. These are easier, right? Negative 1 plus 3 is 2. 0 plus 3 is 3. 1/4 times 4 is 1. 1 plus 3 will be 4. And here it's almost the same. This one's easier though. This is 5/4 plus 3, which would give me 4 1/4. Okay, so these are all my x values. My y values don't change. Negative 10, 0, negative 15, 0, negative 10. Okay, usually you can find nice points to work with, but with this 4 here, it makes it a little more challenging. All right, so now these are my points that I'm plotting, my new points. I'll clearly kind of bracket them off. Okay, so I have 1 3/4, negative 10. All right, maybe I'll try this one in red. Okay, so where is 1 3/4, negative 10? 2 comma 0, 3 comma negative 15, 4 comma 0, and 4 1/4, so just a little bit over the 4, negative 10. Oops. All right, so the shape, there's no reflecting at all, so the shape is mirrored. Like I start with a leg, and then I do a nice, okay, wait, 1 2 3 4 5, 1 2 3 4 5, yeah. I do a nice kind of parabolic shape in the middle, and then my last leg. And I'm going to step back, kind of look this over again. It was supposed to be a horizontal compression, yes, and a shift right. And that looks like it is, right? So in red, my function is f for x minus 3. Now, once again, you could pick different points than me, but I'll just give you a clue. Anytime you can work with intercepts, those are the easiest to work with, because one of your value coordinates is 0, so it's usually easy to work with zeros. Maybe you could get by You still would have to have one point selected on this, on the arms, I think. Otherwise you wouldn't really know the slope of the arms. Okay, questions? Ryan, we okay with this? Yeah? Joanna, Johannes, everything good? Everything okay? Rahel? Oh yeah. Okay, it's very methodical. All right, let's go to example 3 then. I do post these on the blog, right? All my notes and my videos, so you can take a look. If you want to come take pictures of notes too, you can always do that as well later. Sometimes it's hard to see. And if you're having problems seeing, please move up close. There's lots of room. All right. Have you seen this graph before? It's a reciprocal graph, right? What do reciprocal graphs have? Yeah, can you see that on top of the y-axis there's also an asymptote? You have those two, didn't you, Jack? So this graph actually has an asymptote. So I'm just going to, usually a lot of times you'll see asymptotes printed in red just so you can see it a bit better. I'm going to write a little note here. Note the graph of y equals f of x has an asymptote. Okay? Now, asymptotes are part of this graph. It's a member of the graph. So anytime there's a transformation on a graph, every part of the graph is affected. So if there's a shift, left or right, the asymptote's going to be affected too, right? Because it's a part of the graph. So I want to make you aware of that. Okay? Asymptotes are affected by shifts to the original graph, or shifts to the function, I'll say. Okay, they're part of the graph, so they are affected. They will shift along with all other points. Okay, so they're affected too. All right, so let's see what we got here. Unfortunately, these are hard to pick critical points for because the very nature of a reciprocal graph, they want to hug these asymptotes. So what happens is their values get super, super, super small. And it's really hard to read coordinates, right? All I know is that these points here are approaching the value of 0. It's really hard to read points. So select some points that you think might be easy to work with, right? So we're going to have to dig a little bit for some critical points. And here what we could do is we could look at this graph first, just like we did before. They gave us the equation. They showed us all the transformations. So verbally, let's describe the transformations. And this time we have 1, 2, 3 transformations. Agreed? Okay, take a moment and record, just write in words, do little bullet notes about what are the transformations that you see. Okay, who wants to be brave? Who wants to verbally describe any transformations that you see? Excellent. Horizontal stretch by a factor of 2. You want to keep going, Rahel? Vertical. I'll say shift. Is that okay? But you're right. Translation's the better word. Vertical shift 4 down, right? Because if we put it in y equals form, it's that -4. And we've got one more. Excellent. Okay? So you can be asked, and on the test, this is what you'll be asked to do. Look at an equation like this and be descriptive and use words to describe the shifts. That's a common question asked. And now we actually physically move the graph. So what we're going to do is pick some critical points if we can. Just do the best you can. But the best thing you can do is this asymptote is affected. It's not affected by stretches. Because if I multiplied this straight line, and if I took the asymptote, the vertical asymptote is just a straight line, right? If I stretched it, there's not going to be any effect on it, right? It's affected by shifting. Will this vertical line be affected? Yes, because there is a horizontal shift, right? It won't be affected by a vertical shift. If I took this line and moved it up 4, you wouldn't even notice, correct? But would you notice if I took this vertical line and shifted it to the left one? Yeah. So maybe that's the first thing we can do. We can say, note, the new vertical asymptote is at, okay, just shifting over 1, then it will be at the line x equals -1. Okay, so that's what I'm going to do. That gives me my, I'm going to do it in big bold red. This is my new vertical asymptote, x equals -1. That's how we define a vertical line. It's just x equals whatever value it cuts through. Okay, this kind of gives me the area that I'm going to be graphing at. All right, so let's take a look at some critical points. One of them is identified for us, which is kind of nice. I see another point here. That seems okay. This one and this one. Oh, sorry, I should also have said this. Reciprocal graphs, have 2 asymptotes, correct? They had a vertical asymptote. There's also a horizontal asymptote, correct? Is the horizontal asymptote affected at all? Should have said that too, right? Will this horizontal asymptote be affected by a horizontal stretch? No. Would this be affected by a vertical shift? Yeah, the whole graph would be shifted down, correct? Sorry, I'm getting... Maybe what I'll do is I'll do my new asymptotes in blue. Here. I'll do my new asymptotes in blue. So this is my new horizontal asymptote. Y equals -4. There's too much red going on. And this is my new vertical asymptote. X equals -1. Okay? So asymptotes will be affected by shifting. So it looks like this graph, once you do your new asymptotes, you can actually see this whole graph is going to be moved down and a little bit over, right? Which is what it says, down and a little bit over. Okay, we just have to take care of this horizontal stretch. So I've got this point, I've got this critical point of the original graph. I got this point. And may as well do sort of a matching one over here. I'll do this point over here. So it's a little hard to read, right? So I'm going to move left to right, 1, 2, 3, 4. So my first critical point occurs at, what do I have? 1, 2, 3, 4. So negative, when x is negative 2, it looks like y is negative a half. Okay, and then this point here, negative 1, negative 1. And then moving over here, positive 1, positive 1. And then here, positive 2, positive a half. Sort of mirroring the points here, right? And I think I can get by with 4 points since I have my new asymptotes drawn. I know they have to stay in here, and I've got these 4 points. So let's try the math now. Stretch by a factor of 2, so I multiply every x by 2, and I shift to the left, which means I'm getting smaller. And my y's, the only change on the y is 4 down, so it's getting smaller as well. So these just give you little baby equations, right? So you substitute your x value in to get the x value. Negative 2 times 2 is negative 4, minus 1 is negative 5. Negative 2 minus 1 is negative 3. 2 minus 1 is 1. And 4 minus 1 is 3. Okay? So those are all my new x values. The y's are easy. I'll cover up my x values now. I just take my y value and subtract 4. So this will be negative 4.5. Negative 5, negative 3, and a half minus 4, negative 3.5. Okay, this would probably be the toughest type of graph to graph. So, my new points, negative 5, negative 4.5. So here's negative 5. 1, 2, 3, 4 and a half. Negative 3 comma negative 5. 1, 2, 3. 1, 2, 3, 4, 5. 1 comma 3. 1 comma 3. Or sorry. 1 comma negative 3. 1 comma negative 3. Just scratch this out. This is going to be hard, right? See? A little bit. And 3 comma negative 3.5. 1, 2, 3. Okay. So here's my 2 points I plotted. Here are my 2 new asymptotes. Okay, so this one goes here. And then here I plotted, this is hard, right? 1, negative 3, and 3, negative 3.5. Okay, so I have these 2 points plotted. If you can see, I have these 2 points plotted. And here are my new asymptotes. I'm just going to highlight my new asymptotes, okay? So you guys can see what's happening here. Okay, so here are my new asymptotes. I'm just trying to plot these 2 points, right? This one? 2 times 2 is 4. 4 minus 1 is 3, right? Oh, I see. 1, 2, 3. 3, 1, 2, 3.5 here. Okay, gotcha. This one's good though, right? Okay. So here are my asymptotes, right? Here are my 2 points. Sorry. This was very messy, this one. Okay. Now asymptotes are usually left as red, but Kind of a lot going on here, right? So this is my new graph. It's definitely shifted down and to the left 1 unit. It's supposed to indicate a horizontal stretch by 2, and it definitely looks steeper, right? It looks steeper than the original graph. The original graph's a little more shallow in slope. Like I say, it's a bit steeper, right? Oh, I think I'm off this one, right? 1, 2, 3. It's supposed to be here. I can't even read my own graph. Okay. This one's a little off. Okay, that's better. Okay. Maybe we should have started off with an easier graph to look at, right? These two should have been flipped. All right, the purpose of this graph, not to get lost in all the point plotting and it's a little hard to see, I guess the big takeaway from this one, if you found it a little awkward to graph or yours looks even messier than mine, don't despair. The big lesson from this one is I want you to know that if the original graph has asymptotes, they are also affected by shifts. Just remember that. Okay, that's the big takeaway. The only graph that you're going to see with asymptotes right now is something like this reciprocal graph. Okay? Yeah? Okay, let's move on. Let's try something, with, again, lots of transformations, but I want to identify the transformations here because something special is going on here. Here's the graph of y equals root of x. So this time we actually know it's the radical graph, right? Sketch the graph with the transformations by 1 minus 2 equals negative root 3x plus 3. Notice there's no f in here. F is just when it's a generic function and we don't know the equation. We do know the equation. This is the rational graph. So these are the changes on the rational graph. Everyone take a moment, identify the changes, see if you can just jot down in bullet form what the changes are to this graph. I actually see 4 changes. 1, 2, 3, 4. Okay. I have, just not being very specific yet, I have a horizontal compression, agree? Horizontal shift? Vertical shift? Reflection. Okay, so now we have to actually be a little more precise. Horizontal compression by factor of 1 over 3, right? That's the math that we're going to do, right? Horizontal, let's leave that one. Vertical shift 2 up. This negative sign, is that acting on what would that be attached to the A value or the B value? The A value. So it's a vertical, right? It's a vertical reflection. So if it's acting on the Y, that means it's over the X-axis, right? Reflection over the X-axis. I had people asking me about language. You can say reflect over the X-axis, reflect on the X-axis, reflect through the X-axis, as long as I see the word reflect and X-axis, right? The appropriate axis. Okay. Horizontal shift. It's a shift to the left. Agree? One unit left. Who agrees with me? Just Johannes? Joanna? Yeah. It's 1 unit left. Okay, why is it? That kind of goes, it sort of goes hand in hand a little bit with what that homework question was, that shifting question, remember? With the 3 being outside. Okay, why is it 1 unit left? Here's the problem, right? Okay. Yeah, all horizontal translations and compressions. Here, how about if I say transformations instead? Well, if I say transformations, it covers all horizontal transformations. So if there's more than one, right? If there's a horizontal stretch compression and a shift, must be in factored form before actually translating, right? Before graphing. So you can identify the actual transformations. Okay, kind of a trick in a way. It's not intended to trick you intentionally. It looks neater in this form. It's a nicer way to write it. If we write it if we multiply through, get rid of brackets and collect like terms, it looks nicer. It's easier to type into a computer program or a graphing program, but it doesn't tell you what actually is going on. So anytime, that will never happen to Y's, right? Because the A and the K are separated. It only happens to horizontal transformations because they are located together inside a set of brackets or under a radical sign, so they can easily be multiplied through collected like terms. But in order to see what's actually going on, you have to have this in factored form. Okay? So note, in factored form, the equation is, okay, y, I'll move the 2 over as well, minus root, okay, well you guys know how to factor this, 3x plus 3, how would I factor that? Right, just factor the 3 out, and then a plus 2, right? So now clearly you can see, okay, yeah, it's still 2 up, horizontal compression by 1/3, reflect over the x, and this is 1 shift to the left. So just pay attention. If there's a B value and a horizontal shift, you have to factor things out. Okay, so I'm going to do my real quick. Radicals are really easy. You should always be able to transform a radical with 3 points. 1, 2, and there's usually a third that lines up nicely. Okay? So this is just my regular radical, my pure radical, nothing's been done to it. So it's always going to have the point 0, 0, right? Because the square root of 0 is 0. The square root of 1 is 1. And the square root of 4 is 2. So again, radicals are really easy, especially compared to that reciprocal we just did. Okay, so now we just have to make sure we do all the math appropriately. So your verbal instructions will tell you what to do. Horizontal compression factor of a third, so I multiply my x by a third. And then 1 unit to the left, that's getting smaller, right? And then vertical shift 2 up. Reflect over the x-axis. So basically, a reflect over the x-axis, it's just telling you all the y's become their opposite sign. So I show that all my y's become their opposite, and I add 2. Okay, so order of operations, these are what your little equations are in. They're in the proper order. So you always do your multiplying first, then your add, subtract. So a third of 0 stays 0, and I subtract 1. So I'm just doing all my x's first. A third minus 1 is negative 2/3. 4/3 minus 1 leaves me with a third. The opposite of the opposite of y, add 2. Well, that's just going to stay as a 2. The opposite of 1 is negative 1. Negative 1 plus 2 is 1. Opposite of 2 is negative 2. Negative 2 plus 2 is 0. So these are little, not as nice to graph either because of those thirds, but so negative 1 comma 2, that's my new starting point. Negative 1 comma 2, that's my new starting point. Negative 2/3 comma 1, it's about right here. And 1/3, positive 1/3, 0. Okay, so be very careful. This is my starting point. So the graph, there's just an end here. It doesn't go any further, but this is where the arrowhead is. So if you want to do another point, you can do another point, right? So this is my equation of y equals negative root 3 bracket x plus 1 plus 2. Now let's take a look. It was supposed to be compressed, shifted left, so it is compressed. It's much tighter at the beginning. Shifted left, yes. Shifted up, yes. And flipped over, pointing in the opposite direction, yes. Okay. All right, how about you guys go take a break? Go take 5-10 minutes, and then I'll keep going, and we'll see how far we get. I'm going to go check on the print